So we want to use Lagrange multipliers to find the maximum minimum given that f of xy is x squared times y plus 3y squared minus y, and the constraint is x squared plus y squared has to be less than or equal to 10. Okay, so what we're going to do is set the partial derivatives equal to each other, and I'm going to define g of x as just x squared plus y squared minus 10. So the partial derivatives equal to each other with lambda in there, and we want to satisfy the equation x squared plus y squared is less than or equal to 10. Okay, so for us, let's find the partial derivative with respect to x is 2xy, and then the partial derivative of g with respect to x is just 2x, and we're going to multiply that by lambda. Now to find the partial derivative of f with respect to y, that's x squared plus 6y minus 1. And then we'll find the partial derivative of g with respect to y, multiply that by lambda. And the x and the y's that we find have to satisfy the constraint. X squared plus y squared is less than or equal to 10. So the first thing I'm going to do is work with the first equation. So I have 2xy equals 2x lambda. So a common mistake here will be to divide by 2x, because, what if x is 0? So it's better to move everything to the left side and then factor. Also, when you divide by 2x, you lose one of the factors, so it's not a good idea to do that. Now we can factor out a 2x. We'll have y minus lambda in the parentheses. So we'll have 2x equal to 0 and y equal to lambda. Y minus lambda equal to 0. So you set each factor equal to 0. So x is 0 and y is lambda. Okay, so we found one of the possible max and mins candidates. So in order to find y, I can just plug it into the constraint. So if x is 0, we'll have 0 squared, which is 0, and we'll say y squared equals 10. So y is plus or minus square root 10. Okay, so these are possible candidates, so we'll label that as 1. Now the other thing we have to do is work with the second equation. So that one needs to be worked on, because we have that y is equal to lambda. So let's plug in y equals to lambda in there and see what we get. Okay, so plug that in, I get x squared plus 6y minus 1 is equal to 2y times y, which is y squared, right? Because I'm plugging in y equals lambda here. So I'm just going to solve for x squared to get 2y squared minus 6y plus 1. And I'm going to substitute that in to the constraint equation. So that would just be 2y squared minus 6y plus 1 plus y squared is less than or equal to 10. So simplifying, we get 3y squared minus 6y minus 9. And instead of setting it less than or equal to, we'll just set it equal to 0. So factor out a 3. And actually, we'll skip a step and say, okay, this factors into y minus 3 times y plus 1. Okay, so we get y equals 3 and negative 1. So what's left is we want to plug it into the constraint equation. So we had x squared plus y squared, we'll say equals 10. And if y is 3, we get x squared plus 9 equals 10. X squared is 1, so x is plus or minus 1. And if we plug in y equals negative 1, we get x squared plus negative 1 squared, which is just 1. And so it's x squared equals 9, x is equal to plus or minus 3. Okay, so we have to get all the combinations now. So for plus or minus 1, we plugged in y equals 3 over here. Okay, so plus or minus 1, we plugged in y equals 3. And then for plus or minus 3 for x, we plugged in 1 for y. We have these plus, originally we had, let's see, somewhere here we had x equals 0 and I think y was plus or minus root 10, yeah. So let's look at that as well. 0 plus or minus root 10. Okay, so these are the ones that we have to test. So the way you're going to test it is by plugging it into f of xy. So I'm just going to give you the answer. No point in showing all the work. So I'm going to break these out into each case. So breaking out the plus or minus. So for for positive 1, 3, we get 27. Same thing with negative 1, 3. For 3, 1, oh, it should be negative 1 actually. So I made a mistake here. I did plug in negative 1, not positive 1. So just to verify, yeah, it was y equals negative 1, not positive 1. So that's just a typo. Okay, so 3, negative 1, and negative 3, negative 1 is negative 5. And then if I plug in 0 plus or minus root 10, actually I get, well, for 0 positive root 10, I get negative root 10 plus 30, and then root 10 plus 30. Okay, so clearly this is the maximum. And the minimum is negative 5, so it's these two. So 0 root 10 is neither. Negative 1 plus or minus 1 comma 3 are neither as well. Okay, and that's our final answer.